Dear students, today we will further discuss about iterative structures and more specifically the sequential search algorithm. So actually we are supposing that we have a list, and from that list we want to identify or search a particular element, whether that element is present in that list or not. This means, for example, this can be applied in your class. So if your class is of 50 students and I want to search that this particular student roll number or registration number is present in this list or not, and it has many other applications as well. So searching from the start to the end, of course we have a list, so then we will start from starting point until end. We will be searching until we find the required value or list ends, and assumption is list is sorted. So this means the minimum value is at the beginning and then followed by the maximum values at the last. So let's have a practical example. We have this list which have numbers 12, 18, 29, 38, 45 and so on, and we want to search whether, for example, 45 can be found in this list or not. So for example, we find 45 over here. So we will start from here, from 12, and we will compare that this 45 which we want to search is equal to 12 or not, and we will keep doing it until we find 45. And if we give, for example, we want to search 800, so that 800 cannot be found in this list, and when this list ends, this algorithm will finish, this iterative structure will finish. So this means we will have this statement that select the first entry in the list as test entry, as we have said in the previous discussion that we will get this 12 in the test entry. So let's make a RAM as we were doing previously. So we have test entry over here, and this include 12, and target value which we want to search is 45. So target is 45. So while target value is greater than test entry, so while 45 is greater than 12 and entries remains in the list, so there are more entries available, yes, select the next entry in the list as test entry. This is the procedure we will be working, and between this procedure we will further check that if target value is equal to test entry or not, so whether 12 is equal to 45 or not. If it is not equal, then we will fetch next 18 in place of 12. So then we will be checking 18 is equal to 45 or not, and if that is found, we will say that we have a success, else we will say that we will declare the search facility was a failure. So if we want to write the proper pseudocode of this sequential search function, first of all we have defined def search. So this is the name of the function as we have described, and this is the list. So this list contains all of the list which is available over here. So all of these numbers are basically going to this list, and then this target value which we discussed 45 in our previous example. And first of all we are checking whether if list is empty. This may also happen that there is no list provided by the user, then we can say declare search a failure, that's it. Else if list is not empty, then select the first entry in the list, as we discussed that we have selected 12, the first one, and while 45 is greater than 12, this statement is keep on executing until we find the 45 is equal to 45, and we declare the search result as a success story. So if we summarize today's module, we have developed an algorithm from scratch and represented it in the form of pseudocode for sequential search, and we assume that the list we have is already sorted.